Class?
Yes.
All right, so we have a couple days left before the big food day, right? So 4-day weekend, you guys should be happy about that. But next week, it is going to be the notebook check, so I'm explaining it. Even though I just told you people, there's some people watching online here, okay, sitting at home chilling, okay, watching cat videos, and every once in a while, taking some time to look at some homework notes. So we're going over this. This is going to be page 49. Everyone has these right here, and it says this is going to cover 4.5 through 4.7. 4.5 through 4.7. So we're going to go through and fill in these notes, and it's actually, I like this one better than I like Euler, because Euler you have to use all the edges. So, Hamiltonian path. It's a Hamilton path. I hate it being Etonian. Anyway, so Hamilton path begins and ends at different. The key word is going to be different. At different vertices. Vertices and crosses every vertex exactly one time. Does it cross every edge? Say no. No. Okay, so now we have a story to go along with this. About, not last week, but the week before, I ordered some pizza. Delivered to school.
From where?
Pizza Hut. Just down the street. And they said they can't deliver it because they don't have any delivery drivers. So on the spot, on the phone, I'm like, dude, that's messed up. Offered me a job to deliver pizzas because they don't deliver until at 3 o'clock when their delivery driver shows up. But that's how short people that they are. So he said, yeah, we're paying $20 an hour plus tips. That's not bad, right? But you also have to, that's your car. You have to provide your own car. They don't have like a little meet for you. So if you are driving, if you're doing delivery driving, think of every one of these vertices as one of the houses you are delivering pizza to. Are you going to take every single road to connect all of it? No. You can take the shortest path to go to every single house to deliver each one of those pizzas, right? Yeah. And that's what we're going to do here. So let's take a look. So last time with Euler's, we were trick-or-treating. So I wanted to get all those edges because we go down the streets at every house on the street and get all those candy, right? We get those full-size candy bars in that rich neighborhood. But this time, now we're just delivering pizzas at $20 an hour plus tips. So let's see. I'm going to start here. A, B, C, D, and E. Did I deliver all the pizzas?
Yes.
I went to all the houses, delivered all the pizzas. But did I have to take every single road in between there and there? No. That's the difference right here. So the Hamilton path begins and ends at different vertices. But we went through and delivered all the pizza though. Does that make sense? Okay. So the path is at different. So now let's look at this next one here. Now, I'm going to give you a moment. Go ahead, try it out. Try it out. Like I said, I like these ones more than the Euler's. It's a puzzle. And don't forget, we're delivering pizzas. Are you going to go back to the same house twice? No. You're not going to go to the same house twice. You're just going to deliver those pizzas. So watch this. I'm going to start here at A. And to B, C, F, H, E, G, and D. There we go. Did I make it to all the houses? Okay. So the path, the Hamilton path, covers every vertex but ends at different location. The Hamilton circuit begins and ends at the same vertex. The same vertex. So this goes back to you're delivering pizza. So after you go on a run delivering pizzas, what do you have to do? You got to go back to pick up more pizza. The Hamilton path is you're on your way, you're going to go home afterwards. Do you really want to go all the way back to the place just to go sign out? No, you don't want to put extra miles, right? Like, I'm already close to home. So you take the path all the way home. And you just head that way after you're done. But on a circuit, you have to go back and pick up more pizza. So on the circuit, we're going back and pick up more pizza. So try this one out. Do it. What's that? Yeah, doesn't matter the order. I just don't have to. I don't have to cover every string. This one you have to end up back at the same location. Hamilton circuit is same location. Vocabulary. Come on now. Come on now. All right, let's see what we have. So does anyone have this first one? All right, what you got? You think you do? Okay. Excellent. Yeah, good job. Good job. All right, so now right here. And when we're doing this, what do we have to do that we were doing previously, but I'm not doing on this one yet? What did we do when we were doing our problems last time? Start numbering them, right? So 1, 2, 3, 4, and 5. There's my path. So you can see the numbers that go along with it. All right, and let's see the hare. Does the hare have the next one? No? All right, come on. It's time to redeem yourself. Oh my goodness. All right, did she cover them all? Yeah, good job. Good job. All right, so let me see. We had 1, 2, 3, 4, 5, 6, 7, and 8. Going in that direction. Good job. Now, anyone got questions on that? Now, could you have a different route? Yeah. No, you don't. It doesn't even say where to start. So you can start wherever you want. All right, so let's go up to here. Now, for this vocabulary we have here says complete graph. Complete graph is a graph that has exactly 1 edge between each pair of vertices. And there's another vocabulary, but I'm going to give you some diagrams to go along with complete graph to show you the difference. So let's see. So here we go, right here. So draw these diagrams with this. So in that little place, draw the diagram. Draw these 3 diagrams because it will explain why it is not a complete graph. What's up, homie? Did you just get to school?
Huh?
Is that yeah?
What?
Did you just get to school?
No.
Why are you so late to my class?
It was far.
Huh? It was far?
I was in the 9 building. No, 9 building. 90 building.
900?
Mm-hmm.
Which is just right there?
On the top though.
Oh, yeah. It's almost like from the 900, there's almost like a complete, you know, way to go this way.
I went to the bathroom too.
Oh. All right, do we have them all down? All right, let's see now. And the last vocabulary I have says every complete graph has a Hamiltonian circuit. Every complete graph has a Hamiltonian circuit. There we go. All right, so this first one here, let me explain this first one here, 3 dots. Please pay attention up here. All 3 dots are connected. Each one's connected to each other. Now on this one here, let me change up color to make this a little bit more obvious. Now, this one here is not. This one is not right here. The reason why it's not is because it's missing a line here. It's missing a line, so these two are not connected. And there's also this one here. Oh, that was weird. This one doesn't go directly over across here, and the same thing goes for this one going this way. All those dotted lines are missing. So if it's Hamiltonian, every vertices is connected to all the other vertices. Because the ones I put it in dotted lines right here in black, they're not connected, right? So think of it like this. So if you're going to your friend's house, you would go directly to their house, right? Or if you're like someone else in here, okay, you go to your dealer's house first, then you go to your friend's house, right? Yeah. See, that's one way to understand. So you would have to go to this place here before you go over here. Same thing goes down over here. If I wanted to go all the way to this corner from this corner, I would have to cross through, Candy's dealer's house first. All right? Now, does that make sense? That's the reason why this one is not. This one's a yes. And my last one, what was the last shape? Pentagon?
It was yes. It was yes. No. Yes. It's on the bottom of your star.
Yes. Okay. So, pentagram.
No way you draw your stars like that. That's gross.
And?
No, like the way you started from. It's so weird.
What?
Yeah.
Quit your whining, man.
Gross.
Oh, this is not art class. Shut your pie hole. Now, let's look right here. Oh, what? Do you start from the bottom? Now you're here?
Yeah.
Oh, okay. See what I did there? No. Thank you. Someone needed to help me with that one. All right, so on this one right here, so that's why there's a yes. There's a connection in between every single dot here. So you can go, so if those are all your friends, you can go directly to your friend's house. You don't have to go to someone else's house. That's kind of like messed up. Stopping at your friend's house, be like, hey, hi, how's it going? I'm going over to Carlos's house right now. And you're like, yeah. But you're like, forget you. It's like, hey, yeah, I'm going to go hang out with my homies. But wait, I'm your homie too. Why can't we? Can I go with? No, the other homie doesn't like you. Okay, anyway. Yeah, Jaw here was telling me about that. So I was like, dang. All right. So, drawing a Hamilton circuit. To draw a Hamilton circuit. Now, the word circuit means it completes and goes back to the beginning. In this sense, it's going to be the circuit, so it's going to complete and go back to the beginning. Graph your move first from vertex to vertex until you visit all vertices exactly once on your way back to the starting point. So, this one right here, it is possible to go back through it. Right? So, I'm only going, so if this is the Hamilton circuit, that means that I'm delivering pizzas. Right? I'm delivering pizzas, and then after I'm done delivering pizzas, since it's a circuit, where do I end up at? Back at the store, right? The circuit, you end up back at the store. The Hamilton path, you just go home. You're like, I don't need to go back. So let's see, and since I already did that one, I did this one a moment ago. So let's say, do I have to go through all the, no. Make it easier, right? So this one doesn't have to cover all the sides or all the edges. We could just go straight one to the other. And it says, although every complete graph must have a Hamilton circuit, a graph does not have to be complete. That's important. A graph does not have to be complete in order for a Hamilton circuit to exist. So what that says is, I do not have to go directly to everyone's house. I do not have to go directly to everyone's house. Yeah, for Hamilton, I would go from one house to the other, but in a complete, I would have to go have a line going directly to everyone's house. Does that make sense? Okay, look. This one right here is a complete graph, right? Is there a line connecting this point to all other points? There is, right? So that means it's a complete. So this is complete, this is not. This one right here, this second one is not. So this says if it's complete, I have a line from this house here to every other house directly. This one here, I have to go to Candy's dealer's house first before I go anywhere else. Right? Okay. That's the difference in between it. So if it's not complete, I have to go to the dealer's house first and then go to Candy's house. But then if it is complete, I can go directly to Candy's house without stopping at her dealer. Does that make sense? Okay. All right. So we're going to go ahead and stop here, and then you're going to be able to do the first half of the notes for today, or first half of the homework. So it's the first page and the second, if I'm not mistaken. Let me see.
The answers?
This one right here. So you could do 1, you could do 2, you could do 3, you could do 4, but stop at 5. Because we're going to do 5 on Monday. We're going to do the part that goes along with this, the weighted, on Monday. Okay? don't forget, like, share, and subscribe. Hit that notification button. And follow me on Rumble. I got banned from YouTube for, I don't know. Anyway.